Welcome to a lesson on a linear function application. A local towing company charges $3.25 per mile driven, plus a non-refundable base fee of $30. They tow a maximum of 25 miles. Part A, write a formula for the function c of x that represents the total cost as a function of the number of miles driven. So because our function is c of x, we know the input variable is x, where x equals the number of miles driven, or we could say the length of the tow in miles. Let's go ahead and let x equal the number of miles driven, as stated here. And c of x is the total cost in dollars. So the function formula for c of x is c of x equals $3.25 times the number of miles driven, which would be 3.25 times x, or just 3.25x, plus the non-refundable base fee of $30, so we have plus 30. So this would be the formula for the function c of x, where again c of x is the total cost in dollars, and x is the number of miles driven by the tow company. For part B, we're asked to determine c of 15, so we're going to find the output of our function when the input is 15. So we substitute 15 for x, so c of 15 is equal to 3.25 times 15 plus 30. So c of 15 is equal to 3.25 times 15 is equal to 48.75. And we have plus 30. So c of 15 is equal to 78.75. This tells us when the input is 15, the output is 78.75. So as an ordered pair, this would be 15, 78.75. Which means if the tow company drives 15 miles, the cost is $78.75. Or we could also say a tow of 15 miles costs $78.75. Let's go ahead and state it that way. A tow of 15 miles costs $78.75. Part C, determine the value of x, which is the input, when c of x, the output, equals 82. We're asked to write the answer as an ordered pair and then explain its meaning in a complete sentence. So because we're given c of x, this is the total cost, we're trying to solve for x, which is the number of miles driven by the tow company, or the tow distance. So we'll substitute 82 for c of x, which will give us the equation 82 equals 3.25x plus 30. Solving for x, we first isolate the x term, so we'll subtract 30 on both sides. 82 minus 30 equals 52. We have 3.25x, and 30 minus 30 is 0. So now we have a one-step equation. So we'll divide both sides by 3.25 to solve for x. 52 divided by 3.25 is equal to 16. And 3.25 divided by 3.25 is equal to 1. 1 times x is x. So if c of x equals 82, x equals 16. So as an ordered pair, it's always the input comma the output in our case, or in our case, x comma c of x. So the ordered pair would be 16 comma 82, which means a tow of 16 miles costs $82. And this should make sense because notice on part B, a tow of 15 miles costs $78.75. So one more mile would cost an additional $3.25. And this amount plus $3.25 does equal $82, verifying a $16 tow should cost $82. Now take a look at Part D. Part D asks us to identify the practical domain and practical range of this function by filling in the blanks below, and we're asked to include the units, where the practical domain is a set of all possible inputs or x values, and the practical range is a set of all possible outputs or values for c of x. Remember, x is the number of miles the tow company drives, or the distance of the tow. Well, notice how we're told they tow a maximum of 25 miles, which means x must be less than or equal to 25 miles. But now let's determine the lease value in the practical domain. It is possible to tow a car 0 miles, for example, if you were to call the tow company, and then as soon as they arrived, your car started, you probably wouldn't take the tow, and therefore your tow would be 0 miles, but you still have to pay the $30 non-refundable base fee. So the practical domain would be x is greater than or equal to 0 miles and less than or equal to 25 miles. And now to find the practical range, we need to determine all the possible outputs, or all the possible costs from towing a car or vehicle 0 miles all the way up to 25 miles. Well, C of 0 would be equal to 3.25 times 0 plus 30, and therefore C of 0 is equal to 30. So C of x must be greater than or equal to $30. And to find the maximum cost, we'll determine the total cost at the maximum tow distance of 25 miles, which would be C of 25. So C of 25 is equal to 3.25 times 25 plus 30. So C of 25 is equal to 3.25 times 25 is equal to 81.25. Then we have plus 30. So C of 25 is equal to 111.25, which means C must be less than or equal to $111.25. And for our last part, we're asked to construct a table of values and draw a graph of C of x. And we already know that the input values must be in this interval here. Let's go ahead and select the input values or x values of 0, 5, 10, 15, 20, and 25. And now we'll find the corresponding outputs. But when the input is 0, we already know the corresponding output of C of 0 equals 30. So we know this output value here, which will give us the ordered pair 0, 30. We also know that C of 25 is equal to 111.25. Now we need to find the outputs for the inputs of 5, 10, 15, and 20. C of 5 is equal to 3.25 times 5 plus 30. So C of 5 is equal to 16.25 plus 30. So C of 5 is equal to 46.25. Next, we'll find the output when the input is 10. When the input is 10, the output is C of 10, which equals 3.25 times 10 plus 30. C of 10 is equal to 32.5 plus 30. C of 10 is equal to 62.5. The next input is 15, but in the previous slide we found that C of 15 is equal to 78.75. So the last input is 20, so the output is C of 20. 3.25 times 20 is equal to 65. C of 20 is equal to 95. Now we'll set up the Cartesian plane to graph C of x, where we always find the inputs along the horizontal axis and the outputs along the vertical axis. We already know that the inputs are on this interval from 0 to 25, and the outputs are on this interval from 30 to 111.25. So we only need a positive horizontal axis as well as a positive vertical axis. Let's place the horizontal axis here and the vertical axis here. The horizontal axis must go out to a maximum value of 25 or further. Let's go ahead and scale the horizontal axis by 5s. So 5, 10, 15, and so on. We also need to label the axis, where the horizontal axis represents the number of miles driven or the distance of the tow. Let's write the number of miles driven. Now, the vertical axis must go up to a value of at least 111.25. Let's select a nice value larger than that. Let's scale the vertical axis by 30s up to 120. So we'll have 30, 60, 90, 120. The vertical axis represents the total cost in dollars. Now we'll plot the ordered pairs from the table of values. So the first ordered pair is 0, 30. So the input is 0, the output is 30. This would be the vertical intercept. The next ordered pair is 5, 46.25. So here's where the input is 5. 46.25 would be somewhere in the middle between 30 and 60, let's say approximately here. The next ordered pair is 10, 62.5. Input of 10, output of 62.5, which is approximately here. The next ordered pair is 15, 78.75. Input of 15, output of 78.75 would be approximately here, somewhere between 60 and 90, a little bit closer to 90. The next ordered pair would be 20, 95. Input of 20, output of 95, approximately here. And finally, we have the ordered pair 25, 111.25. Here's where we have an input of 25, output of 111.25 would be approximately here. The graph of c of x will pass through these 6 points here, but it's only going to be a line segment because, remember, the practical domain is when x is greater than or equal to 0 and less than or equal to 25. So it's only going to be the line segment from the input of 0 to the input of 25, so it'll start here and end here. This would be an accurate graph of our function c of x. I hope you found this helpful.